Thank you, students, wherever you are. This is your teacher. My name is Hassan. Today we are learning about simple titration. This simple titration, we have this question. 5 grams of sodium hydroxide solution contains a volume of 250. 2 grams of HCl contains a volume of hydrochloric acid contains a volume of 300 centimeter cubic. So we have the procedure. The procedure says fill the burette with hydrochloric acid. You fill the burette with HCl. Using a pipette, you place 25 centimeter cube of sodium hydroxide in a clean conical flask. Then you add 2 drops of phenolphthalein indicator. Then you carry out the titration. Then you fill the table. So let us go to the question directly. Question number 1 is asking the average volume of HCl used. So to calculate now the average volume of HCl used, we have this volume of HCl used. Sorry, here is 23. Not 20, here is 23.0, because there's a typing error here. 23.0 minus 0, then you have 23, 23, 23, all of them. Then the average volume is 23 plus 23 plus another 23. When you all of them you add, you get 69. Then you divide by 3, which gives you 23 centimeter cubic of hydrochloric acid. So this is the volume of HCl used. Out of 300, we used 23 only. That's the answer of part A. You add all of them. Part B, it's asking the concentration in gram per liter of sodium hydroxide. Concentration gram per liter of sodium hydroxide, we have the mass and we have the total volume. So how do you get it? This is what you do. You take the mass, which is 5 grams of sodium hydroxide. 5 grams is equal to the total volume, which is 250 centimeter cubic. Then what about 1000? 1000 is equal to how much? We don't know the value of 1000. Then you do cross multiplication. For the cross multiplication, you can use an pen. So let's cross multiply it. That means 5 grams multiplied by 1000 centimeter cubic divided by 250. So we will get here we will get the answer is 20 grams per liter. So we have part C. In part C, it's asking the concentration in moles per liter. Concentration in moles per liter is always equal to molarity. It's called molarity. Molarity, therefore, is equal to concentration in moles per liter means molarity. Molarity is equal to concentration in gram per liter, which we have obtained here, divided by the RFM. RFM, of which solution? The question C is asking the concentration in moles per liter of sodium hydroxide. Sodium hydroxide. So the solution that they are talking about is sodium hydroxide. So the RFM of sodium hydroxide, RFM of sodium hydroxide is equal to, sodium is always 23 plus oxygen here is always 16 plus hydrogen is 1. Then in total you'll get 40 gram per mole. The RFM is always 40 gram per mole. So therefore, how do you get the RFM? How do you get RFM? RFM, you get it sodium hydroxide 23, sodium 23, oxygen 16, hydrogen 1, then total 40. Then this is what you do. Therefore, molarity is equal to concentration gram per liter, which is this one that you have here, which is 20 gram per liter, over RFM, which is 40. So this gram they will go together, then you will get it 0.5 molar of sodium hydroxide. So this is the molarity of sodium hydroxide. So that's what you do it to get the molarity of sodium hydroxide. We have part D, the number of moles of sodium hydroxide used. To get the number of moles of sodium hydroxide used, you use this molarity, this new molarity that you get 0.5 is equal to 1000. What about the volume used, which is 25 centimeter cubic? So let us open a new page, add a new page, that is part D. but D therefore will say 0.5 mole is equal to 1000 centimeter cubic, because the molarity of any given value always equal to 1000. What about 25? Where am I getting this 25? The 25 is the volume of sodium hydroxide used that I show you in the pipette, the one that you are pipetting. Then cross multiplication, 0.5 mole, therefore multiplied by 25 centimeter cubic. Then what about 1000? What about 1000 centimeter cubic. Then you do cross multiplication, you cancel it, this one and centimeter cancel it. Then you multiply 0.5 times 25, 0.5 times 25 divide by 1000. The answer is, if I'm not wrong, the answer is 0.00125 moles. This is the number of moles of 0.0125 moles. This is the number of moles of sodium hydroxide used. This is the number of moles of sodium hydroxide used. Okay, but D, then we have part E. So let us go back part E, previous page. So part E is asking the number of moles of HCl used. To get the number of moles of HCl used, you use an equation. Okay. You use an equation. The equation is you react the two solutions. Sodium hydroxide aqueous plus hydrochloric acid aqueous. Then we'll get an arrow. The product is sodium. My eraser. Where is my eraser? Please, my eraser, help me. What is this? I have never seen such kind of sodium, the way they're writing. Okay, sodium chloride. My pen is becoming another level. Okay, sodium chloride aqueous plus water. This is a reaction between acid and base, neutralization reaction. So let us balance it. Sodium here 1, sodium here 1, balance. Okay, hydrogen here 1 plus 1. This side, product side, reactant side, we have 2 hydrogen. Here we have 2 hydrogen, balance. Oxygen here 1, oxygen here 1, balance. So both sides it's balanced. The mole ratio is 1 to 1. The mole ratio of sodium hydroxide to hydrochloric acid is 1 to 1. Since the mole ratio is 1 to 1, the number of moles also remains the same. The number of moles of hydrochloric acid will be the same with this one. 0.0125 moles of HCl is used. So the number of moles of HCl and the number of moles of sodium hydroxide remains the same. The reason being because the mole ratio is always 1, 1, 1. Since the mole ratio is 1, 1, the number of moles remains the same. So we have another question. Let us go question E. Up to E we have the question F. Question F, it's asking the mass of sodium hydroxide used. So the mass of sodium hydroxide, how can we get it? How can we get the mass? Question E, the next is F. Question F, mass is equal to number of moles times RFM or RAM. So the number of moles of sodium hydroxide we have here. This is the number of moles. So the number of moles is 0.0125 moles. Then we multiply times the RFM. What's the RFM of sodium hydroxide? We have already obtained it here. The RFM is here. We have calculated sodium 23, oxygen 16, hydrogen 1. We got it 40. It was 40. Therefore, times 4 times 40. What do we get then? What do we get? The answer is 0.0125 times 40. Then we get 0.5. The mass is 0.5 gram of sodium hydroxide is used. This is the mass of sodium hydroxide used. So that's how you do it. But we have but F. That's how you do the but F. You have the number of moles, you multiply the RFM, then you get the mass. So let us also see the next question. The next question here is question G, which is the last question. The percentage purity of sodium hydroxide. How do you get the percentage purity? The mass that you obtain right now, which is the mass used, divided by the original mass, which is 5 gram. This is the original mass, 5 gram, divided by the mass used. Then you multiply 100, then you minus 100, then you get the percentage purity. So let us do that. Let us do that. Let us get a new page. That is question F. Question G. After F we have G, F, G. Yes, G. Yes, I'm right. F, G. We have G. Question G therefore will be percentage purity. Percentage purity therefore is equal to mass used. Mass used here, I mean mass. Let me use my eraser. So let me use percentage purity is equal to mass used over total mass over total mass times 100% times 100%. Mass used is how much? Let us see it. The mass used here in sodium hydroxide, the mass used, we have 0.5. This is the mass used. This is the mass used, 0.5. Then where is the total mass? Where is the total mass? The total mass of sodium hydroxide here, 5 grams centimeter cubic. So therefore, we will say mass used is 0.5 gram over the total mass, which is 5 gram times 100%. Then in this case, gram and gram they cancel. Then when you multiply, I think you'll get 10. 0.5 divided by 5 is 0.1 times 100, which means you get 10. So the answer here is 10. So the answer is 10%. So this 10% you subtract minus 100. You say 100 minus 10. Then what do you get? 90%. So the purity is 90% pure, meaning that 10% is impure. So that's how you calculate it. The purity of sodium hydroxide is 9% pure and 10% impure. So please subscribe our channel, because every day I do upload a new video, a new lesson. And this is symbol titration symbol. We are going to see something called symbol titration complex. Our next lessons, what we are going to learn is symbol titration complex. So symbol titration complex, that's the one they bring always in the exam. But this one is very simple. It's symbol titration symbol. If I pass over one time without wasting my time, we have these two questions, these two solutions, sodium hydroxide and hydrochloric acid. First question is asking average volume from the table. Then you add the 3 volume of HCl switched, which is 23. Then you divide by 3, then you get 23. So the second question is asking molarity. Concentration in gram per liter. You said the mass is equal to 250 of the sodium carbonate. What about 1000? Cross multiplication, you'll get this one. The question C is asking molarity. Molarity, you use the formula concentration gram per liter of RFM, where RFM you can get it adding all the compounds, 23 plus 16 plus 1, then you get 40. You divide your concentration, which you get in part P, 20 divided by 40, then that's what you get. Then question D, it's asking the number of moles. To get the number of moles, you have the molarity 0.5 of the sodium hydroxide is equal to 1000. What about 20 25 the volume used. You get the number of moles.